Hello. So this is our homework assignment. And I hope you are uh, trying to do this because it is very important for your final examination also. So today we will try to do one question or part of a question from sampling section. Okay. So here question 14, 15 and 16 as well as 17. No. No, up to 16, 14, 15, 16. These questions are related with sampling part. Okay, so I hope you are trying to do this. Okay, so please try to find the answers for these questions. We already has discussed these things, have discussed these things in our tutorial class and as well as lecture class also. Okay, so so we will so I hope these questions are not much easier, not much difficult. I think those are very easy question. Okay, uh, so we will try to do this kind of composite signal. We will try to find the sampled signal of this kind of composite signal. Okay, so I think you already know these things. Okay, the sampling theorem means the Nyquist sampling theorem. That means our sampling frequency should be greater than twice of uh, the signal maximum frequency of the signal. Okay, so that theory should be applied here directly to find the sampled version and required minimum sampling rate. Okay, so we will try to do this. Okay, so anyway, I will leave this question for you. Okay, and I will get identical problem. Okay, so, okay, so let's say we have a composite signal. Okay, let's say that is xt. So we have a composite signal xt is equal to 20 cos to 5 10 t plus 10 cos to 5 30 t or something. This kind of question, this kind of signal. Okay, so we are asked to, so we can see that if we see our question. Okay, so it is said that the minimum sampling frequency is 40 Hz. So minimum, sampling frequency already given. Okay, and we are asked to find the sampled frequency according to this sampled signal. Okay, so here, okay, here, okay, we will try to do this. Okay, so we will try to find the minimum sampling rate required for this signal. Okay, so you already know that the sampling frequency, we can say omega s, okay, should be greater than or equal sampled frequency. Okay, this is the continuous time signal frequency. Okay, and this is sampling frequency. Okay, so this is sampling frequency. So this is information information signal frequency. Okay, signal frequency. So you know that if we have one signal, say for example this one, okay, so let's say this is x1 and this is x2. Okay, so if you consider x1, okay, if you consider x1 is equal to cos 20 cos 25 10 t. Okay, so this is a continuous time signal x1 t. We can say it is x1 t. Okay, x1 t. Okay, so this is the frequency, this is the frequency of the signal, but this is normal frequency, fs, sorry, fm. Okay, this is the normal frequency. Let's say it is fm1. Okay, this is the normal frequency, it is fm1. Okay, so I think you can see that we can directly, so this is here I have written the angular frequency, but if you use the normal frequency, the same result you will get, no? The omega s equal to 25 fs, okay, should be equal or greater than to 25 fm. Okay, so you can see that, sorry, 225 fm, okay, because 2 is there, 225 fm. Okay, so this is omega, no? 25 fs means omega s, 25 fm means omega m. Okay, so you can see that 25 will cancel out and you will have the same identity. Fs is greater than or equal to fm. Okay, so here we are given, so here we can find fm directly. Okay, fm directly. Okay, fm. Okay, so here fm1 is equal to 10. Let's say this is hertz. Okay, this is in hertz. Okay, so it is 10 hertz. So to sample this signal, what is the minimum frequency? Minimum sampled frequency we need. Okay, so you know that this is the sample frequency, fs should be greater than or equal to fm. Okay, so the minimum sampling frequency is, okay, fs, let's say it is minimum, should be equal to 2 fm, no? So this is the minimum sampling frequency. That means it should be at least equal to 2 by twice the information signal frequency. Okay, තේරුණාද කියපේකනේ මේක එතකොට minimum sampling frequency එක අපි දන්නා sampling frequency එක fs කියන එක විශාලයි හෝ සමානයි 2fm. මේ fs කියන්නේ sampling frequency එක, fm කියන්නේ information signal එකේ frequency එක. එතකොට sampling frequency එක වැඩි වෙන්න ඕන information signal එකේ frequency එක වගේ අඩුම තරමේ දෙගුණයක්. හරි. එතකොට අපිට අවශ්‍ය මිනිමම් සාම්පලින් ෆ්‍රීකවෙන්සි එක කියන්නේ මෙයා සමාන වෙන අවස්ථාවක් නේ. ඒක තමයි මෙයාට එන්න ඕන මිනිමම්. අඩුම තරමේ ඒ ගානවත් තියෙන්න ඕන. සමාන වෙලාවක් තියෙන්න ඕන. සමාන හෝ ඊට වැඩි. එහෙනම් අඩුම සමාන වෙලා තියෙන්න ඕන. හරි. එතකොට fs කියන එක මිනිමම් කියන එක සමාන වෙනවා 2fm එකට. Okay. Okay, so we will continue. Okay, so what is the sampling frequency here? Minimum sampling frequency, fs1. Let's say it is fs1. Okay, so it is equal to 20 hertz. No, it is equal to 20 hertz. Okay, so if you sampled this signal from 20 hertz, okay, 20 hertz, you will have this kind of signal, no? So it is xn. Okay, so you already know that n is equal to, sorry, t is equal to nts. Okay, so to find the n, xn, we can directly substitute this identity instead of this t. Okay, you already know that, so we can substitute this. So we have cos 25 10, and here it is NTS. Okay, so what is TS? So you know that Fs is 20 hertz. So TS means 1 by Fs, no? 1 by Fs. Okay, so TS is 1 by Fs. So it is, we can say that 20 hertz, no? Fs is 20 hertz. Fs is 20 hertz. So it is N by 20 hertz. Here you know that TS is equal to 1 by 20. So NTS, N by 20. So I apply here it. Okay. Then අපිට මෙතන කෙලින්ම n බෙදීම 20 දාන්න පුළුවන්. Okay. So here we have the sampled signal. So it is equal to 2 cos 25. This is 10 by 20, that is 0.5 n. Okay, so this is the frequency of the sample signal. So this is called nominalized frequency, no? Nominalized frequency. Why we called it nominalized frequency? Because this nominalized frequency we got our first frequency, our signal frequency FM is divided by the sampling frequency. So that is why we call this nominalized frequency. Okay, so this is the nominalized frequency. So this is the sampled signal. Okay. Okay. So so if we consider, if you consider this 20 hertz, okay, if you consider this 20 hertz, if you want to sample this signal also, okay, so you have X2 signal. Okay, so you have X2 signal. Okay, so if you sample this X2 signal, what is the X2 signal frequency? It is 30. No, it is 30. Let's say it, I will write it here. Okay, so this is X2 signal. It is 30. Okay, it is 30. So we will try to, so this is, let's say this is FM2, that is equal to 30 hertz, no? Okay, so what is the minimum frequency which is needed to sample this signal? Okay, that is twice this frequency, no? So the minimum sampling frequency Fs2, let's say it is Fs2, should be equal to 60 hertz, no? 60 hertz. So at least we have to sample this signal from 60 hertz. Okay, otherwise we can't reconstruct it. We will get aliasing effect, no? If we use some frequency, some sampling frequency lower than this one, 60 hertz, we can't reconstruct this sampled signal correctly. Some information will be lost. We will get a distortion signal. Okay, so we called it aliasing effect, no? So we have the distorted signal if we sample this signal with the frequency lower than 60 hertz. Okay, so you can see that we have to sample that one with 60 hertz. Okay, so if you sample, so here the first signal minimum sample frequency is 20, no? Minimum. So this signal minimum sampling rate is 20. Okay, so this signal minimum sampling rate is 20 hertz, and this signal minimum sampling rate is 60 hertz. Okay, so what is the minimum sampling rate to rate for this total signal? Okay, what is the minimum sampling rate of this total signal? It should be 60 hertz, no? If you select this 20 hertz, so it is not enough for this signal. 20 hertz is not enough for this signal. 20 hertz sampling rate is not enough to this signal. Okay, but this signal, it is enough. Okay, but this signal information will be lost. But if you choose this 60 hertz signal, okay, it is enough for this one, and it is more than enough for this one. No, so you will get very nice signal here. Okay, here also you will get normal signal, but here you will get more preferable signal if you use 60 hertz. Okay, so the sampling rate for this total signal is 60 hertz. Okay, so I think you can directly find it, no need to go through this step. Okay, so you can check the, if you have more component also, if you have more component, so you can choose the maximum, what is the maximum frequency of this composite signal. So whatever you get the value for maximum frequency, the minimum sampling rate should be twice of that maximum frequency. Okay, so you can keep remember this point. Okay, you can keep remember this point, and you can directly get. Okay, no need to waste your time. Okay, hari මම හිතනවා තේරෙන්නේ නැති කියලා එක. දැන් මෙතන සිග්නල් එක තියෙන්නේ මෙයාගේ ෆ්‍රීකවෙන්සි එක 10, මෙයාගේ ෆ්‍රීකවෙන්සි එක 30. හරි, එතකොට මෙයාව සාම්පල් කරන්න ඕන මිනිමම් රේට් එක 20යි, මෙයාව සාම්පල් කරන්න ඕන මිනිමම් රේට් එක 60යි. හරි, එතකොට මෙයා අපි දැන් මේකේ 20 කියලා තෝරාගත්තොත් එහෙම සාම්පලින් රේට් එකට මේ මුළු සිග්නල් එකටම, හරි, මෙයාව හොඳට සාම්පල් වෙනවා, ප්‍රශ්නයක් නැහැ. මෙයාගේ සාම්පල් ටික අපිට ඇති වෙයි රීකන්ස්ට්‍රක්ට් කරගන්න. හරි, ඔකට්ටියට මම පස්සේ මේ ලැබ් වලදී කියලා දෙන්නම් මේක සමහරවිට මේ දෙක ගත්තා කියලා, ඒ කියන්නේ දෙගුණයක් ගත්තා කියලා හරියටම රීකන්ස්ට්‍රක්ට් කරන්න බෑ ඇත්තටම. Okay, I will do it in a lab session. Okay, we will see it in a lab session. If you get the minimum as twice the frequency, sometime it is not, it may be not enough to reconstruct the signal. Okay, but in mathematical, in with some condition we can do this. Okay, but always we can't do this. Okay, hari කොහොම හරි අපිට මෙතන 20න් මෙයාව හොයන්න පුළුවන්. හරි, 20න් හොයන්න මෙයා රීකන්ස්ට්‍රක්ට් කරන්න පුළුවන්. හැබැයි 20න් මෙයාව රීකන්ස්ට්‍රක්ට් කරන්න බෑ, මොකද මෙයාගේ 30ක් තියෙනවා. අඩුම තරම මෙයාට 60ක්වත් ඕන. එහෙනම් අපි 60 තෝරාගත්තොත් එහෙම මෙයාව රීකන්ස්ට්‍රක්ට් කරගන්න පුළුවන් කොහොම හරි. හරි, මෙයාව ඊට වඩා හොඳට රීකන්ස්ට්‍රක්ට් කරගන්න පුළුවන් නේ. මෙයා 60ක් කියන්නේ තව සාම්පල් මෙයාගේ වැඩිපුර එනවා ඇතුලේ. ඒ කියන්නේ මෙයා හොඳට රීකන්ස්ට්‍රක්ට් කරගත්ත හැකි. You will get more sample here, so you can reconstruct the signal very properly, very preferably. Okay, so you have to select the maximum rate as 60. හරි, ඔකට්ටියට එතකොට කරන්න තියෙන්නේ මේ වගේ component කීයක් තිබ්බත් ඉස්සෙල්ලා මේ component එකකින් එක බලනවා මොකක්ද maximum frequency එක කියලා. maximum frequency එක තියෙන එකේ දෙගුණයක් ගන්නවා මුළු සිග්නල් එකට. මෙච්චරයි කරන්න තියෙන්නේ. හරි, ඒක තමයි sampling frequency. Okay, so we will do this. Okay, so I will select as the sampling frequency as 60 hertz. Okay, then I will sample both signal. So you know that if the sampling frequency is 60 hertz, then what is the sample time? Sampling time 1 by ts is equal to fs. So what is the sampling time? Ts is equal to 1 by fs, that is 1 by 60 hertz. No, so this is the sampling time, sampling duration. This is sampling frequency. Okay, so we have found the minimum required sampling frequency and maximum sample duration. Okay, so we will write it in terms of the n. Okay, that means with the discrete variable. So you already know that t is equal to nts. So to find the xn, we can directly substitute this value for t. Okay, so you have 20 cos 25 10t, no, 25 10t. Yes, 25 10t. This is 25 30t. Okay, 10 25 30t. This is 20 cos 25 10t. Okay, so we have 20 cos 25 10 t. What is t? It is n by 60. Okay, plus 10 cos 25 30. What is the t? It is n minus 60. So this is the sampled signal. Okay, so you can try to simplify this further. So this is 1 by 6 n plus 10 cos 25 to 5. This is 1.5, no? So half n. So this is the nominalized frequency. Okay, so this is the sample signal. Enough, no? So only 2 minutes is enough to solve this kind of question. Okay. So we will see this in MATLAB as usual. So you can get the idea very clearly. Okay. So I will try to show this in MATLAB as usual. Okay. So I will try to type the signal. I will clear all the variables. Okay. Then first we can define the t. T we can define from 0 to I will get a very small step here, because now then we can we read this t as a continuous variable. So I get very small steps. So we can view this as a approximately continuous value, not taught. It is not a continuous value. It is indeed a discrete value, but we can view it as a discrete. Okay, so I will take a very small point, let's say 0.3 or something. Okay, because you can see that here here the frequency is somewhat bigger. It is about 10 and 30. That means within 1 second there may be 10 circle. No, within 1 second there may be 10 circle. So we no need 10 circle. I think 1 or 2 circle is enough, no, to view the things. Okay, so that is why I select this this end t is very near value. Okay, so that we can view only 1 or 2 or 3 circles. Okay, if I put this very high value, there is much circle. Okay, so we can't see the things inside that circle. Okay, so that is why I put very small value here. Okay, so I think it is better to understand this one also. Okay, තේරුණානේ කියපේකනේ මම මෙතන දශම 3 ගත්තේ. දැන් මේකේ පේනවා කට්ටියට ෆ්‍රීකවෙන්සි එක ගොඩක් වැඩි කියලා. හරි, මේක එකක් 10 එකක් 30. ඒ කියන්නේ දැන් මෙයා ගත්තොත් එහෙම මෙයාගේ තප්පරයක් ඇතුලේදී සර්කල් 10ක් තියෙනවා. එතකොට තප්පරයක් ඇතුලේදී සර්කල් 10ක්. ඒ කියන්නේ එක තප්පරයකට දශම 1 දින එක සර්කල් එකක් එන්නේ. එතකොට අතන මම දැම්මොත් එහෙම ගොඩක් වැලියු එකක් දැම්මොත් එහෙම සර්කල් ගොඩක් එනවා. එතකොට අපිට view කරගන්න අමාරුයි. සර්කල් ටික එන්නේ එක ළඟ නේ. ඒකින්ද අපි ටිකක් අඩු මේ t value එකක් ගන්නවා. හරි. right. So then I will okay, so this is you got this, and I will directly type my waveform x, let's say x1 as usual. X1 is equal to 20 cos 20 sorry, 20 cos 2 pi, 2 pi 10 ft, 10t, 10t, 25 10t. Okay, so x2 is 10 cos 2 pi 30 t, 30 t, 30 t. Okay, so x1 we sorry, we have to put that multiplier here. Okay, so we have this, we have our signal, so we can get x as x1 plus x2. Okay, so we can directly plot this, plot t with respect to t, this x1. Okay, I will put it as we will give a color. Okay, I will give yellow or something. Okay, light color. Okay, so I have to type the hold on, otherwise we can't plot all the plots in one diagram. Okay, so we have t. Now I am going to plot x2. I will put it as green. Let's put it in green color. Okay, so then finally I can plot here. Before plot, I have to write the hold on. Okay, so plot t. So composite signal x. Let's put it red, some dark color, no? Okay, now if you see 3 waveform, sorry, x1, this one should be equal, x equal x1 plus x2. Okay, so if you, so you can see that, this green signal, this is the green signal. So you can see that a green signal, the amplitude is high. Okay, amplitude is high, sorry, frequency is high, amplitude is low, it is 10. Okay, so you can see that signal. And for this yellow color signal, amplitude is 20 and frequency is 10, no? So it has very low frequency, so you can see that. So this is our composite signal. Okay, this red color is a composite signal, so it is not purely sine wave, no, sine or cosine wave. So it is the addition of two sinusoidal wave. So you can see that this kind of signal. So this is the red signal is our information signal. Okay, so you can see this. Okay, then we will sample it. Okay, so what is our sampling frequency? Fs, it is 60, no? So I will try to do it with 20. Okay, if you don't have any objection. Okay, but this is not the correct sampling rate, no, because we can't if you sample this with 20, you can't reconstruct that information signal. We will see it. Okay, so here fs. Okay, now ts, sampling rate, it is 1 by fs. Okay, 1 by fs. Then I define the n. Okay, so n means the number of sample, no? So it should be a definitely it should be a discrete value. So I will get only one step. So I will get 0, 1, 2, 3, 4, 5, 6 for n. Okay. So I will, let's take 10 sample. Okay. So I will get 10 sample, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sample. Okay. So, so now we can write our discrete version signal. Okay. So these two, okay, I will get these three signal. Okay. So this discrete, so discrete signal I will put D here. Okay, so x1 D n, okay, with n. So here instead of T we have to put n T S. No, instead of T we have to put NTS. Here also I have to put NTS. Very simple. Okay. Okay. So you can plot it. So here also I will, this one also I will mark as D, discrete signal. So this one also discrete. Okay. And this one, X1 also should be discrete signal. X2 is discrete. Okay. So this, this is the sampled signal. This is the sampled signal. Okay. And this is the sampling signal, composite signal. And this is sampled composite signal. Okay. So we we have to plot discrete signal. We will use stem command for that. Okay. So you can see that I think you can remember that if you choose n here, okay, you can't get corresponding discrete signal because n have 1, 2, 3, 4 value. Okay, but you know that this n always should be mapped with t. So the condition is t is equal to nts. No, so in that way we have to map this n with t. So you have n ts. Okay, I have used here t1 because this t and this t will to avoid the confusion. Okay, so I will put this as t1. Okay, so we have to plot our signal with respect to t1 time value. Okay, not with n. So if you choose n, so that is the time value. It will take as a time value, this n. Okay, this n will take as a time value. Okay, so you will have 1, 2, 3, 4 at time 1, at time 2, at time 3, likewise. Okay, but that is not a correct answer. No, we have to, this n is referred number of sample. So this n should be mapped to t time. Okay. So here t1 is there, and I will write x1d here. Okay, x1d. I will okay, we will see this separately, x1d. Okay, and I have to use, hold on here, don't know. 10 t1. Okay, t1 t1 x2d. Okay, this is here also need, hold on. So then I will plot the composite signal, composite discrete signal with respect to t1. Okay, that is x d. Okay, so these are our three discrete signal. I think if we write, if we try to plot all this value in one diagram, it will not be clear. Okay, so what is the problem? S is not undefined. What is the line? Line 18. here 18, here TS. That should be TS, T simple S. Okay. So you can see that all these signal you can't view very clearly, but we will try. So you see that, okay. So you see that this is our, this yellow one is our high frequency signal. Okay, sorry, low frequency signal. So you can see that we have one sample here, and one sample here, and one sample here, and one sample here, one sample here. So I will plot it one by one. Okay, otherwise you can't see it. Okay, so first we will consider this x1. Okay, first signal. Okay, so I will remove this, otherwise you can't receive it. So I'm going to plot only this x1. Okay, so hold on, hold on, command. Okay, and here also other signal no need. Actually this one no need to comment. Okay, because if the plotting is the problem, so we will only comment this plot part. Okay, so we should have only x1. Okay, so I will hold this one. Okay, so if we go it, okay, it happened. I can't see our x1. Yeah, this hold on should be there. Okay, one hold on should be there. Sorry. It should be command. Okay, between this two hold on should be, we have to put hold on here. Okay, between the plotting we have to put the hold on. And I think it is okay, it will be okay. Yeah, you can see that. So this yellow color is our signal. So you can see that we will have one sample here, one sample here, one sample here, one sample here, likewise. So you can see that we can somehow, up to some level, we can reconstruct the signal. No, we will get this kind of signal. Here one line, here one line, one line, one line, one line, like this. Okay, so approximately, so you will have sawtooth signal, not sawtooth. What is that signal called? It is a triangulating signal, no? Like this. We will have it like this. Okay, so we don't have this smooth part. We will have just line here when we reconstruct the signal. Okay. I can't write here. No. Can't write. So here to here straight line will be there, and here to here also straight line will be there. Okay, so you can see that somehow we can reconstruct the signal. So I said that this is not enough actually in practical scenario, because if you sample one sample here, you will get other sample here, another sample here, another here, then you will not get the signal. Okay, so we will see it in practical session. Okay, we will try to see it in practical session. So it is happening. Okay, if the sampling is start at this point, it is okay. Somehow we can reconstruct approximate signal. But if the sampling is start at here, then this another sample is here, and another sample is here, another sample is here. So you will have 0 value all. So there is no signal to reconstruct. Okay, so that thing practically happened. Okay. Okay, so you can see that. So if we try to see x2, okay, now I am going to plot x2. Okay, now I am going to plot x2. Okay, and here also I am going to plot x2. This is x2. Okay, here the sampling rate is 20, no? So you can see that if you try to recover this x2 signal, okay, x2 signal, okay, x2 signal, what happened? You can see that one sample is here, one sample is here, one sample is here, one sample is here. So you will get this kind of signal, no? One here, one here, one here, one here, one here, one here, like this. Okay, so that is not our intended signal, no? So you will get this signal like here, like here, like here, this kind of signal. Okay, wait a minute. So you can see that if you sample this this 30, this is this sample is the frequency is 30 hertz. Okay, and if you sample it with 20 hertz, you can see that you have sample here, 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 likewise. So if you reconstruct the signal, you will get this kind of signal, no? It is not the yellow signal, our information signal. So many information is lost. This information, these are lost. We will get this kind of signal. So you can see that to sample this signal, the 20 hertz is not enough definitely. So you have to get, okay, so you have to get at least 60 here. Okay, 60. So if you get 60, so now you can see that here one sample is here, one sample is here, one sample is here. So you can now construct this kind of signal, no? This kind of signal. So this is okay, no? Okay, up to some level, this is okay. You can approximately without loss, within some condition, you can reconstruct the signal. Okay, so let's now see the composite signal. Okay, now I will remove this plotting also. Okay, now this is the composite signal. Okay, now I take the composite signal. Okay, and here it should be, this is the composite signal. Okay, so I will choose 20, frequency is 20. Then I will try to go this. So you can see that, okay, so you can see that okay, so you can see that once one point is here, one point is here, one point is here, one point is here, no? So if you get this signal, okay, if you get this signal, you will get like this. It is just like a sine wave. Then some information is lost. Okay, this information will be lost. So you can see that you will get that only 10 signal, no? Cos 20 cos to 5, 10 signal you will get if you sample it with 20 hertz. Other signal is lost, no, that information. Okay, So this is not enough. The sampling rate is not enough. So if you put here 60, I think that will be enough. Okay. Yeah, it is somewhat enough. No, no, now you have sample here, 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 like this. Okay. Okay. So you can see that now we have sample here. You can't edit this one, no? You can't get a pen here. I don't know how to edit here. Okay, so anyway, I will get the pen document. So you can see that. Okay, so you can see that. So you can see that. Now you can see that. Okay, you can see that you have one point here, one sample here, one sample here, one sample here, here, here. So your reconstruction will be like this way. I will get another value, we will get another color. Okay, so this way. Okay, so this way, and like this, and then this here, like this, like this, like this, you will get. Okay, so this kind of signal you will construct. So you can see that it is somewhat very similar to our composite signal. No, because, if you choose 20, you will get only this point and this point. So this information is not there at all. So you will get this kind of signal, no, like this, from here to here, here to here, like this. Okay, so that is not okay. So this is somewhat okay. Okay, so I think you got it. If you have put here 0.2. So you can see that I will put 12 here. Sample number of sample 12. So you can see that here we have this kind of signal, no? Here, like this, like this. These are the sample. This blue circles are the sample. Okay, samples. So you can see it very clearly. One like this. So you will get the signal. Okay. So if you get more value, if you get more sampling frequency, that is very good. No, you see this time you will get the very accurate signal. No, here I will choose 100. So you will get here this information is also there here, like this. No, like this you will get. And if you put more sample, it is more recoverable. Okay, so you have to choose the very low T here, otherwise you get, because yeah, if you choose the number of sample, very large sample, then again we can view it here, not 12. Okay, let's stay 20,000 or something. So you can see that here very they get the sample very near, in very near point. Okay, we will put some value. I think this will be okay. We will put 120 sample here. And 120 sample, 60. I have 3 times, so here 12. We will get 3 times, about 30 sample, 40 sample, 36, 40 sample. So see, you can get many sample here, so you can very accurately draw the signal. No? If you just join this sample value, you can very accurately draw the signal. Okay, so I hope you get this idea. Okay, so we will stop here and we will try to do another one.